All right, guys. So, quick explanation of some magnesium stuff. Excuse my messy office here. But I wanted to go over a few things about differences between aluminum and magnesium. Everything that I'm showing you today is magnesium, with the exception of one aluminum rail that I'm going to compare to a magnesium rail. So, first off, magnesium finish. Now, magnesium can look very, very shiny. There are certain areas that will turn out real shiny depending on how it comes out of the mill, and other times it can be very, very tarnished. So that has to do with oxidation. So when tarnishing, oxidation, it basically when a part leaves the CNC, it will end up with a with some either mineral oil from the cutting process left on the surface, or the coolant has to be changed from a water-based coolant to purely a mineral oil-based coolant for machining magnesium. And depending on how it's treated, if it's cleaned off immediately afterward and not handled with the hands and just set on a bench, oftentimes it will end up nice and shiny, because a microscopic oxidation layer will form. Basically, any material, aluminum does the same thing. It begins oxidizing instantly once it's been machined, as soon as the oxygen touches it. And anyone that does welding knows what I'm talking about on that. You try to clean the surface off, and almost immediately it's beginning to oxidize and is difficult to weld. But magnesium is more reactive than aluminum in that regard. And so if it comes off the mill, like, it's really shiny right there, and yet this part was machined a month ago maybe. But this part was machined at the same time. So what will tend to happen is the environment within the shop and the humidity in the air, as well as how it's handled just with the fingers, and what's done regarding cleaning of the part after the machining process, will dictate whether or not it ends up with some level of tarnish or oxidation on the surface. Now, that that surface look is it. I'm not 100% sure why some parts will tarnish or oxidize more rapidly than others, but I can tell you though that you can clean all of that off. Mothers, the company that makes aluminum polish, they make aluminum and magnesium polish, partly because there's a lot of magnesium automotive wheels, motorcycle engine cases. Volkswagen, I believe, Volkswagen Beetles had magnesium transmission cases. So Mothers makes polishes for magnesium. You can also just, believe it or not, you can use vinegar. So this magnesium frame rail initially was all black on the surface, and I think I treated it 3 times with vinegar and water, just and with a spray bottle, and let it sit for a bit. You could see it bubbling. Wiped it off. Did it again. Wiped it off, and it took it down to this dull gray. And usually magnesium is a dull gray. Now this. Let me flip these over. So this is not raw aluminum. This is silver anodized, but I had no raw aluminum to show the difference. But you can see that magnesium does not look as shiny as silver anodized aluminum. Again, it can. I mean, that's pretty shiny. Switchblade rail center section here is shiny. But then you see the wheel. This is an aluminum wheel with a magnesium beadlock ring and magnesium side cover. But if you can see the edge of the rim in there, the rim itself is aluminum. But most magnesium parts. So here's a magnesium foot pad. It almost looks gross on the surface. The back side, there's areas that are kind of tarnished and areas that are shiny. Let's see here. This is fender deletes. You can see the top side. The delete fin we also can make in magnesium. It's ridiculous how light this stuff is. It feels like plastic. I mean, there's nothing to it. There's a magnesium ice block. And so we can make virtually any of our aluminum products in magnesium. Magnesium has different properties than aluminum. People say it's weaker than aluminum. Well, not really. It has some favorable properties and some not as favorable properties versus aluminum. One of the things we are going to do, however, is on the back side of the rails where you don't see it, this area is the highest loading because you're just adjacent to the axle. So you're standing here and putting cantilevered or extended loading on this part of the rail. So when you're pushing down on it, this area is under compression. This area is under tension. So in fact, you can see this area is broader than the rest of the rail, and we've done weight-saving cutouts out here, but the weight-saving cutouts aren't as much nearer the axle. And so that was for more strength. But we did that with the aluminum rails initially. But with the magnesium, I think what we're going to do is make this area far thicker, both top and bottom on each side of the axle. It will not be seen from the outside at all. It's only going to add a tiny, tiny bit of weight, 8, maybe 10 grams at the very most of weight per rail, but they're already crazy light compared to the aluminum, so that really doesn't matter. But we're going to be doing that. So magnesium has interesting properties. It has a very dead feel to the board. So it has a different resonant frequency versus aluminum. So magnesium is, in a high vibration environment, it's preferable in a certain way. It tends to absorb vibration better than aluminum does in most frequencies. Now, this board is virtually all magnesium. I mean, it's like every part you can see is magnesium. This board is great. It's got a cool dead feel to it as you're riding it. You can tell it's absorbing vibration. But when under hard braking, there's one point at which I can really feel that the board is starting to vibrate. And it's kind of a fascinating thing because it's only at the one frequency. As I come to a stop, I can hear, as the motor is kind of that whoop sound, there's a point at maybe 4 miles an hour or so right before I stop that I can really hear it kind of go, and it vibrates right at that frequency. It's fascinating stuff, magnesium. The motor sounds different with the magnesium beadlock rings and side covers because it's got a different resonant frequency. But one primary difference between magnesium and aluminum, well, the main difference is that magnesium is 35 to 40% lighter than aluminum, depending on the alloy of magnesium that you're comparing to what alloy of aluminum. AZ31B versus 7075, there's like a 39 or 39 and a half, basically 40% weight difference. It's more like 35, 36% weight difference versus 60, 61. So it depends on which alloy you're comparing, but basically 35 to 40% lighter. Magnesium is fascinating in that the microscopic, or I believe they call the crystalline structure of magnesium. So all materials have a fatigue life. Generally speaking, steel has the greatest fatigue life of the common materials that we use every day. Aluminum will work harden more than steel. So as aluminum is cycled, is bent and straightened, aluminum will work harden and crack more easily than steel will. And again, it depends on the alloy, but I'm just painting with a broad brush here. So all aluminum parts will eventually fatigue. So you overbuild them and whatever. They do still have a fatigue life, but you can build it as such that you're never really going to encounter it in the life of owning the product. Magnesium, and as you add material to aluminum, you can increase its fatigue life, but it still has it's got a finite fatigue life. It's not infinite. Now, with magnesium does also, but in a different way. Magnesium has, below a certain loading, it has an infinite fatigue life. And now I've just been doing research mainly on AZ31B, but there's AZ91D. There's various different alloys that I've looked into. And AZ31B, from a strength versus fatigue life versus corrosion resistance, seems to have the best balance. AZ91D has better corrosion resistance, but has other properties that are maybe a little bit less favorable in our application. So I'm sticking with AZ31B. Good stuff. AZ31B, if you research it, has, in essence, below a certain load range, it has an infinite fatigue life, meaning that it will essentially last forever below a certain load range. It will just not fail. But above that load range, AZ31B, well, all magnesiums really, but above that load range, the fatigue life drastically cuts off. Like, it's really short. And so something about the lattice structure from an atomic level, or on an atomic level, the lattice structure is such that it will absorb a certain amount of movement and never crack any of those inner lattices, but they all tend to let go at a given loading. And so magnesium, again, under a certain loading, and that loading is relatively high. I mean, it's not like you got to be real gentle with it, but magnesium, it will tolerate infinitely. Then all of a sudden you go above that threshold and its cycle life goes way, way, way down. And so that's the problem that magnesium has. And this is, I think, why certain motorcycle parts, I mean, large castings they'll make out of magnesium and that, but other parts like swing arms and that are cantilevered, they'll tend to just make out of aluminum, because you can better count on what the fatigue life is. Now with switchblades, there's just so much material in the center. I'm not worried about them in the slightest. It's the 357s that I have just some concern on. I rode these for quite a while without any issues, but again, we're going to add material in the center just to compensate for, if indeed we're nearing that critical fatigue life loading issue. So that's kind of an explanation there. But again, each part, you're going to get some odd surface look on some parts, whereas other parts are going to show up real nice and shiny. I have no control over that. That's going to be the customer's responsibility to use light sandpaper or mother's polish, whatever you want to use to bring the parts to the surface finish that you're looking for. And so again, foot pads, deletes, ice blocks, rails, 357 switchblades, toe jams, footholds, even wheel side covers. We cannot make the entire wheel out of magnesium, and that's a whole nother topic for a whole nother video, but we can make side covers and beadlock rings. So that I need to get pricing on yet, but that's to be determined yet. But so that's my long explanation. There's a lot more to this, but that's kind of a general over. Oh, one last thing, threads. So magnesium is fascinating stuff. It's fine to thread into, but magnesium is, remember that fatigue life thing I was telling you? The fine threads on magnesium is different. With aluminum, if you start a screw maybe a tiny bit cocked on an angle or whatever, it'll kind of find its way and straighten itself out. Magnesium has less tendency for that. Magnesium threads really want the screw to be nice and straight, and magnesium threads don't work as well dry as aluminum. Now, number one, you should never thread a screw into a part and both parts are totally dry. There has to be some form of lubrication. It could be, I like using anti-seize, but if you want to use thread locker, the thread locker acts as a lubricant as the screw goes in. It also acts as an electrolysis barrier between the material of the screw threads and the material that of the hole that you're threading into. So with magnesium, you have to be more careful. You don't just throw the board together haphazardly and jam screws in holes. Make sure they're lined up, especially bumpers. Everyone knows that the bumper holes, stock bumpers, aftermarket, doesn't really matter. Stock rails, aftermarket rails, you're always got one or two bumper holes that don't want to line up all that well. And what I will do is use an X-Acto knife to just kind of slightly carve out the plastic on the bumper if there's a spot where you can tell the hole is slightly offset from the rail, just so that the screw starts the threads nice and straight. Once the threads are started, it's fine. but you want to make sure that it's a little bit more critical. It's not like you got to be super gentle and, you know, whatever. The threads are strong. They're just less tolerant to the screws starting incorrectly, if that makes any sense. So I think that's it. Yeah, I will be doing more videos on this stuff as I have additional information for you guys.